Hi, everyone. Thank you for joining this session, which is Pickup Analysis Automation powered by XSOAR. And before we start, I'd like to introduce myself. So my name is David Baumstein. And before we dive into the session, I'd like to introduce myself, my group, and provide some background about the use case demo and XSOAR in general. So I've been in IT and later on in security for over the last 10 years. My security experience started out from the endpoint perspective and then through the world of SIEM, SOC, and now security automation. And I've joined a bit over a year ago Demisto, which was at the time acquired by Palo Alto Networks, and later on to be rebranded as Cortex XSOAR. So what's in it for you for this session? So our focus is going to be around pickups, automations, and what do we actually gain from it? It will actually be eliminating much of the manual process that you're probably doing today. It will help you to save time, effort, and fatigue, and do all of this from a single management console. So I'll provide you with some context as to what Cortex XSOAR does. Cortex XSOAR is formerly known as Demisto, which is synonymous as the industry standard for SOAR. So the SOAR acronym stands for Security Orchestration, Automation, and Response, which means that this is actually a platform which allows you to automate much of the SOC and other operations. So orchestration stands for running all of your operations from a single platform. Automation is to automate processes using scripts and integrations and playbooks. And finally, your response is for incident management, collaboration, and investigation. We cover many aspects such as security operations, IT operations, the SOC investigation process itself, threat intel management, and many others as well. So let's dive into some key concepts of XSOAR. First of all, integrations. Integrations are actually sets of commands that utilize other product APIs. For example, PAN-OS firewalls, XDR, VirusTotal. We support hundreds of products out of the box, including, of course, all of the relevant Palo Alto Networks products. Automations are scripts within XSOAR that allow you to perform various tasks, such as parsing data, calculations, checking conditions, and many others as well. And playbooks, you can think of them as flowcharts in which each object can be an integration or an automation command. Playbooks take these integrations and automations and line them up in the proper order and logic, which enables you to complete your processes, and all of this in a fully customizable manner. So here is an image of a playbook. So you can see that we have some tasks, conditional tasks. We align all of it in a manner that the outputs of one command can be used as the inputs for another command. So let me give you like a very common use case of what you would do with an XSOAR playbook. For example, you are ingesting an incident from your EDR, which provides you with some IOCs, maybe a hash, maybe an IP address. Using integrations and playbooks, these IOCs can be enriched to be determined if they're malicious or not. Based on the outcome, we can automatically block these indicators on relevant systems and even run searches on our SIEM to understand which other assets, besides the one that generated the alert, are actually related or affected. So by using XSOAR, you can automate a great deal of your SOC activity and operations. So hopefully now you get some context about what XSOAR is, which will make this demo, hopefully it will make much more sense to you. So the use case that I'm demoing here today was very interesting for me to do because it is a part of our effort to automate important aspects of forensics. It deals with what is a very common issue, both for SOC and researchers, as well as that it leverages many open source capabilities that we were adding as a part of our automation suite. Unlike the many of our other integrations, playbooks, which tend to stay on the tier 1 level, or security operations, this specific use case, I feel, makes the progress to the tier 2 area. Another important note is that we don't just want to show here the tools and what they do, but even more importantly, we want to get the feedback from the teams and community, and hopefully get suggestions where we can improve and how to take this even to the next level. So let's dive into the use case itself. So whether you're a researcher or a SOC analyst, I assume that you're no stranger to working with PCAP files. So the why do we actually need PCAP files in the first place? So you may receive a PCAP as part of an investigation, as evidence. Perhaps you're conducting malware research and you're investigating the network traffic generated in context with that malware. Let's move on to the where. How do we get these PCAPs? So potentially we can record them on the endpoint itself. Maybe we're getting them from the network using port mirroring or a tap, perhaps even from your firewalls. As we do in PanOS, we can configure actually rules that perform recording of network traffic and get the PCAPs from there. So we covered the where, and let's move on to the what. So what do we actually do with those PCAP files? First of all, you'll want to analyze and search within them with tools such as Wireshark, which of course requires you to use the UI for Wireshark or the T-Shark, which is the command line version. The process of working with PCAPs can include searching for objects of interest, such as IP addresses in use, ports, protocols, domains, and you may actually want to dive into the actual payloads for specific protocols, for relevant data. Different protocols have different objects of interest. HTTP packets contain URLs, HTTP methods, user agent, etc. Other protocols such as DNS, SMTP, SMB will have entirely different objects of interest. So you'll need to be familiar with all of the relevant objects of interest for each of these protocols. So you've analyzed and found your objects of interest. You're able to extract those indicators from the PCAP. You'll want to then enrich them using various threat intel engines. All of them have their own UI, and you need to be familiar with all of their capabilities. You've performed your enrichment. You have to make notes of all your findings. In case you have HTTP, SMB, or even FTP traffic, then you can actually extract files within these PCAPs. Those files you also want to enrich, investigate, upload them to the sandbox, detonate them, and later on get the report. So as you can see, we're dealing with quite a few tools here. We mentioned Wireshark, we mentioned our threat intel tools, we mentioned the sandbox, and I'm pretty sure that you have many other tools in your toolkits as well. So of course, this might seem very interesting, but I'm pretty sure that after doing this for a dozen times, hundreds of times, maybe even thousands of times, some of these tasks will eventually cause you to reach a point of fatigue. And many of them tend to be very repetitive, and because of that, also prone to error. So after investigating lots of indicators, uploading lots of files to your sandbox, you might have a pretty good chance that you'll miss out on the most important thing that you were actually looking for. So my guess is that you would also prefer to invest your resources and be part of the investigation that requires you to think and not just do these repetitive tasks. So to summarize, I think it's pretty safe to say that we've identified a couple of key pain points. So as we said, all of this effort is going to cost you time, and a lot of it, you're going to perform very repetitive tasks. You have a multitude of tools that you need to be proficient with all of them. And not to forget, there's too many indicators. You actually need to separate what's relevant, what's not, what's benign, what's malicious, kind of like separating the wheat from the chaff. So I think we pretty much established what's the issue here, what's the problem, and let's talk about the solution. So as it happens, we released two very relevant automations that cover many of the types of tasks that we've just covered here. I like to think of them as a Swiss Army knife for working with pickups. So first one is the pickup miner, which is essentially a script that leverages the capabilities of PyShark, which is the Python module for Wireshark. It supports CAP, PCAP, and PCAP-ng files, and some of its capabilities include displaying and ordering the PCAP according to conversations, using Wireshark filters to extract or create even an entirely new PCAP to create smaller PCAPs to work with. You can search regex patterns. You can parse different protocols to find their objects of interest. You can extract indicators. You can decrypt wireless traffic, provided you have the password. And you can even decrypt SSL traffic as long as you have the RSA certificate to decrypt it. So next one is its sibling automation, which is the pickup file extractor. It's based on T-sharp capabilities, and it can actually extract files from pickups for a few supported protocols such as HTTP, SMB, FTP, and a few others. We can apply filters exactly to which files are we extracting according to the file extensions or their actual MIME type. As you know, it's not that difficult to rename the file extension. So let me show you a quick usage of this automation to run in a command line format. Okay, so this is XSOAR. I'm now going to upload a file. Okay, this is our pickup. It got uploaded. Just a sec. Okay, so this is the automation. I'm going to provide it. This is the pickup file that we want to analyze. I can provide a few additional arguments, such as extract IPs, extract strings, and I want to get the FTP protocol parsed. Okay, in a few seconds, the automation completed. So if you look at this, I think it's pretty much, it looks kind of like the Wireshark protocol breakdown. And what did we actually get by running the automation? So I can see all of our conversations, all of the streams, the source IP, destination IPs, and the protocols in use, and ports, etc. And even more interestingly, we have the FTP parsed and broken down exactly into the objects of interest. So you can see the exact commands that the user executed here. You can actually perform searches. And if you run this later on, all of this is available for you to perform additional actions on. So this is displaying how we're actually using it in the command line format, but that's not what I actually wanted to show you. Okay. So to make the most of everything you saw here, we're not going to use this in a command line. We're actually going to use this in playbooks. So for this, we've created several playbooks. First one is pickup search, which allows us to search for common objects, such as IP addresses, CIDR ranges, ports, protocols, or any custom Wireshark filter that you may want to use. And we have pickup parsing and indicator enrichment, which actually extract indicators from the pickup file and runs the various threat intel engines that we have on it, and also parses the data just as I demonstrated right now. And third one is pickup file carving, which allows us to extract the files actually themselves from PCAP, files that they kept are within the PCAP for such as HTTP files, SMB files. We're then able to run enrichment on those files and detonate them within a sandbox. So you can use each of these playbooks individually. Each of them has its own inputs. But for our demonstration, I've wrapped all of them into a single playbook, which will show the entire flow and capabilities that we've just discussed here. So let me share that. Okay, so this is the pickup analysis playbook. This playbook has actually all of the playbooks that I just mentioned here as sub-playbooks. We have our main playbook inputs. Each of them is relevant for the different capabilities that I've just mentioned here before. But what interests us here is this input that I've provided here. I want to look for this specific IP address. So once we've provided it, the playbook starts to run, and we're automatically using the pickup search playbook. Let's have a look what's going on there. So it received from its parent playbook the input for the IP address that we want to search. So as you can see, we can perform various types of searches on that playbook. We can search according to ports, IP addresses, protocols, and even use advanced Wireshark queries. And naturally, you can combine, you can add a couple of objects to search for the playbook provided as inputs. And what we'll do is actually combine all of them. You can also control the operator if you want all of these objects to be run as an OR query or an AND query. But this time I provided just the one IP address. So what you can see here, this is immediately creating it in a Wireshark syntax to search for that object. We're executing the pickup miner automation. We're getting its outputs. And we're sending all of the relevant result to the relevant incident fields. I'll explain about that a bit later on. And the first playbook actually completed. It ran in a few seconds. And then we're actually moving on to the other playbooks here. So provided we actually found any results from the first playbook, we're running the second one here, the parsing and enrichment playbook. So what we've got here is that we're taking the exact query that we used from the first playbook. We're running it again against the PCAP, and we're searching for relevant indicators that we can extract from the PCAP. So here we're searching for email addresses, IP addresses, and URLs. So we can define as part of these playbook inputs exactly what are our internal IP ranges, what are our external IP ranges, what is our domain, so we can distinguish between internal and external domains and URLs. So let's focus here on the IP section. So we found an IP. We're running this automation. This automation is able to determine that the non-routable IP addresses are actually internal, and all of the routable ones are external. And we've provided an input that we actually want to enrich the IP addresses that are considered to be external. So you can see right here, this is actually executing virus total, autofocus, recorded future, and any other relevant threat intel engine that we actually have enabled. So we're providing it with these IP addresses, and we're getting back results from all of these various engines. Not to mention the fact that we are also doing some parsing here. So we have extracted the URLs, we've extracted the IPs, and let's go into specific protocols. We have the DNS protocol. You can see that it's parsed as a request, response, types, anything else that can be of interest in DNS. And look at the HTTP protocol. We've got our HTTP methods, we've got our user agent, we've got any possible relevant data that we can extract from HTTP, and all of this is available for searching and to be used for our task later on. So this playbook also completed, and simultaneously to it, we're running the file carving playbook. So the file carving playbook looks like this. we're providing an input as to which file types do we actually want to be extracted. And we're providing a query in order to create a smaller, less noisy pickup to work with. So here we're creating the new pickup according to the query. And here we're performing the carving. And as you can see, I've told it extract PE files. And indeed, we've extracted a PE file. Here is the metadata for it. Here is the SHA-256. And then we're performing enrichment with our enabled threat intel engines and getting responses. And they tell us this file is not good. It's marked as bad or suspicious. And we've enabled that we can actually upload these files to the sandbox by auto-detonating it. And once it's detonated, then the playbook actually completes. Okay, so I've shown you here what's going on with regards to all of these playbooks, but what do we actually do? There's tons of data that we got from all of them, and it's all stored obviously in XSOAR, but how is it accessible to you? So one of the great benefits of using XSOAR is that you can also fully customize the layouts of your incidents. For example, this layout here shows all of the relevant data about the pickup file, the flows, the unique IP addresses, the protocols in use. Here we can actually see all of the indicators that we were able to extract from it. And this is the file that we've uploaded to the sandbox. If I click on it, okay, here are all of our threat intel engines. Here is autofocus. Here is all the detail that it can provide me. Also have recorded future, virus total, and you can enable many others as well. And we've actually added another summary page, which provides you like the most critical data, which is the autofocus tags. You have a direct link to download the wildfire report from XSOAR, and we even rasterized the report itself. So you can open it, okay, and you can do all of this from a single platform without actually going to the UIs and working directly with all of those other tools that we've mentioned here. Okay, let's just switch back to the slide. So we've covered what is XSOAR. We've covered how it can help you with automating working with PCAPs. And as I mentioned, all of the things that we saw here, including the automations and playbooks, are all available on GitHub. Additional links here include actually our documentation portal. And if it really interests you, then you can go on to training. We have several online courses for XSOAR that you can take. Thank you very much. It's been a pleasure. Bye-bye.